Draw an FBD of a car moving at constant velocity on a straight road, including drag force. So we're not going to say there's no drag forces and no friction in this example. But let me draw first kind of a sketch of this, and it doesn't have to be good like I've said before. And I'm saying that again because I know this one's probably not going to be good because I don't know if I'm that good. I'm just going to draw maybe, I don't know, 2 tires here. And I don't know, I'm just going to kind of put in something here to represent sort of some part of this car. Okay, I don't know what kind of car that is, but that's going to be good enough for my car here. It's moving at constant velocity, so I can put that in my picture. Again, don't put that in the FBD, right? And I think, we're saying at constant velocity, so there's no accelerations because it would have to be changing its velocity in order for there to be acceleration. Let me just draw a point over here for the FBD, and what can I start with? I think I'll put in gravity, right? So gravity always points down. I think mathematically it's nice to just say F sub g, in other words, F with a subscript to describe forces. It makes sense that there might be a normal force since this is on a level surface that probably is counteracting gravity, preventing the car from falling through the surface of the road in that sense. So that's going to be a normal force. But now this time we said including drag force. So there's maybe air drag, right? I mean, this car is like, it's not doing this in a vacuum, so there's probably air drag. There may also be rolling friction in that sense, which make it a little bit, you might say like, well, what does that comprise? I mean, I think there's elastic forces in the tires. There's maybe also adhesive forces of the rubber as it goes over the road and stuff like that, especially if it's performance tires. They tend to have a bit more of that, kind of keep them glued to the road in that sense so that the car doesn't lose traction. But all of that can be summarized maybe really simply by saying, okay, here is a drag force. Now, if these were all the forces for this car, what would the car really be doing? I think, the 2 vertical forces kind of cancel each other out, and this one would indicate that the car would have to be slowing down. So we need some other force. Well, the car has an engine, right? Does the engine apply a force to the car? My answer is no. The engine makes the wheels go around. And when the wheels go around, they push on the road, and then the road pushes back on the car in the form of a traction force. And that's actually what really maintains the car's motion and really is kind of balanced against that drag force. So I'm going to throw in here a 4th force and call it maybe F sub t for traction. So that's the answer that I'm giving. And I think now let's look at the slide. We'll see it in slightly different form, maybe slightly better drawing. So there's the car with the velocity. Much better done than the version I had, right? Here comes the FBD label to make things clear. There's the system point. There's the gravity force. There's a label for it. There's a normal force. There's a label for it. And now there came that drag force. And I think the label there is drag. And then there's that force, that last one. And that one wound up being the traction force.